So now, what if x is a function of, say, two variables u and p, and y is also a function of two variables, say u and e? Then what will we have? And again, our z, as usual, is a function of x and y. So z is a function of x and y. Then from 5, we can write del z by del u as del f by del x into del x by del u plus del f by del y into del u by uh, del y by del u. And again, similarly del z by del p is del f by del x into del x by del p plus del f by del y into del y by del p. Well, that's enough for the theory. We'll dive into some problems to understand these concepts more. So let's take this function. So question number 1, if u is equal to x cube plus y cube, where x is equal to a and I should not say a, but a cos t, and y is equal to b sin t, then find du by dt and verify. Well, we won't verify, we will just find du by dt, or I should say that since it's the first problem, we will verify the above result. So to find du by dt, we know that u is equal to x cube plus y cube, but this is, our x is a cos t, so it is a cos a cube cos cube t plus b cube sin cube t. Therefore, my du by dt is a cube into 3 times cos square t into sin t plus b cube into 3 sin square t into cos t. Well, differentiation of cos is minus sign, so this minus 1. So this is 3 b cube sin square t into cos t minus 3a cube cos square t into sin t. So we need to verify the above result. For that, to verify, we will use the formula. So by formula, we have du by dt as del u by del x into dx by dt plus del u by del y into dy by dt. So del u by del x is 3x square is 3x square into del x by dt. So from here, well, from here you can find that this is minus a sin t plus del u by del y is 3y square and del y by del t is b cos t. So b cos t. which is 3. X square is a square cos square t into minus a sin t, then plus 3 times y square is b square sin t, so b square sin square t and b cos t. So again rewriting, we will get this as 3b cube sin square t cos t minus 3sa cube cos square t sin t. So notice that this equation 2 and equation 1 are same, hence formula is verified. Is verified. Now for the next example, if f of xy is some z where my x is a function of two variables, e raised to u cos v, and y is also a function of two variables, e raised to u sin v. Then I need to show that y into del z by del u plus x into del z by del v is e power 2u into del z by del y. So I need to prove this. So I will mark this as star. So I will start with the LHS. What is my LHS? Y into del z by del u plus x into del z by del v. Note that del z by del u is given by del z by del x into del x by del u plus del z by del y into del y by del v. So del z by del x is del z by del x. I will keep this quantity as it is and evaluate this. So what I will have? Del z by del u. So del z by del u is simply e power u cos v. So this is del z by del x into e power u cos v. And then I'll keep this quantity as it is and del y by so del y by del u is again e power u sin v, which is, note that this is x del z by del x plus y del z by del y. Also del z by del v is by definition or by formula it is del z by del x into del x by del v plus del z by del y into del y by del v. So this quantity del z by del v is now minus e power u sin v del z by del x plus e power v e power u cos v into del z by del y. Notice that e power u sin v is our y and this quantity is our x. So adding these two with multiplying with y, So we will have here, y multiplied by, well, I should write this on some upper side so that I could get the clear view. So my LHS is y times x del z by del x plus y del z by del y plus x times minus y del z by del x plus x del z by del y. So this is xy del z by del x plus y square del z by del y plus x square del z by del y and minus xy del z by del x. Note that this quantity gets cancelled. So we will have del z by del y multiplied by x square plus y square. We'll write the values of x square plus y square. So our x is e power u, so it will be e power 2u because we are squaring the term, cos square v plus e power 2u sin square v. So we can take e power u common and write in front. So e power 2u into del z by del u into cos square v plus sin square v. From the class 10 identity we can say this is 1. So that's why we are ended with e power 2u into del z by del u, which is our RHS. Hence true. Now let's move on to some other problem. So problem number 3. If my u is a function of y minus z, z minus x and x minus y. So it's a function of 3 variables. Then prove that del u by del x plus del u by del y plus del u by del z equal to 0. So I will assume that y minus z is r, z minus s, z minus x is s, and x minus y is t. So my u is a function of r, s and t. So therefore del u by del x by formula it will be del u by del r into del r by del x plus del u by del s into del s by del x plus del u by del t into del t by del x, which is, I'll keep del u by del r as it is and evaluate del r by del t. So note that del r by del t is 0 plus del u by del s into del s by del x, which is minus 1, and then plus del u by del t will get plus 1. So we will remain with del u by del t minus del u by del s. Similarly, we'll calculate del u by del y. This will be del u by del r into del r by del y plus del u by del s into del s by del y plus del u by del z, instead of z there is t. So del u by del t into del t by del y. So this is del u by del r into, since we are differentiating with respect to y, it's 1 del u by del s into 0 minus, or I should write plus first, it's minus 1. So this will be del u by del r minus del u by del t. Similarly, you can see that del u by del z will be del u by del s minus del u by del r. So therefore, del u by del x plus del u by del y plus del u by del z will be addition of all these three. So I will have del u by del t minus del u by del s, del u by del s plus, I will write this quantity first, the above one for z1, del u by del s minus del u by del r, and notice that the last quantity is for y, which is del u by del r, del u by del r, and minus del u by del t. So notice that this del t will cancel with this del t, then till del u by del s gets cancelled with this del u by del s, and finally del u by del r will get cancelled with del u by del r. So this is 0, which is our RHS, which is RHS, hence proved. So we'll discuss one more problem. So question number 4. If my u is y minus x upon xy, comma z minus x upon xz, then, well, I will simply say find del u by del x. So by formula we have del u by del x will be, I should say, before starting this, I should say my y minus x upon xy is r, and my z minus x upon xz is s. So u is a function of r and s. Therefore, by chain rule, del u by del x is del u by del r into del r by del x plus del u by del x into del s by del x. So del u by del r we don't know, so we will keep this as it is, into del r by del x. We want to calculate del r by del x. So what's our r? This one. So this will be, square of the denominator is x plus xy whole square, xy into differential of x, so minus 1 minus y minus x into y. Similarly, del u by del s into, this will be x minus z not x minus z, it's x into z. So x into z whole square, xz into minus 1 minus z minus x into z. So we will have del u by del r into minus xy minus y square plus xy divided by xy whole square plus del u by del s into minus xz minus z square plus xz whole divided by xz whole square. Note that these two will cancel out. So we will be remained with y minus y square upon xy whole square. So it will be minus x square del u by del r minus, again we will have x square del u by del s. So again resubstituting, I will say this is my, well, I won't substitute, that's enough. So the actual question says, to prove that, what we need to prove, x square into del u by del x plus y square into del u by del y plus z square into del u by del z is 0. So calculating these two, I will leave it as homework. You can do it, and you can verify with the answer if you want. Thank you.